So we look at the states of matter. Naturally, matter can exist in four states, but we are more used to three states. And today we'll be looking at the major three states of matter. The states are one, solid, liquid, and gas. There's a fourth state which is not mentioned much in integrated science, that is called plasma. But in general, we are going to concentrate on these three states. So we look at solid. Okay, so when we talk of solid, what are basically solids? Someone will say solid is something which is hard. Generally, we know that matter can exist in three states, but there's a new state of matter which has been discovered called plasma. But for integrated science, we'll be concentrating much on the three states of matter which we've learned from our childhood. So we'll start looking at what is called solid. Solid. We say solid is a state of matter which are having molecules which are closely packed. There are other forms of matter which are also made of atoms. Some are of molecules, some are atoms. That means the building block. So in short, we said solid is a state of matter. It's a state of matter with closely packed building blocks. With closely packed building blocks. Now, what do I mean by this? The building blocks are closely packed. And I did not mention, or I did not give any name for the building block, but I just use building block because the building block of some solid can be in atoms, some can be in molecules. So we got molecular solid, that these are solid that are in the form of molecules. Common example is toothpaste. It's solid, but you can see it is not so tight like the cream we use in our various houses. They are solid. Ice block is also solid, but the building blocks are molecules. So you can't compare that one to that of metal, like sodium. Sodium, the building blocks are in a form of atoms. The atoms, the individual atoms are put together to form sodium. Another metal you can make mention of is like aluminium. The building blocks are atoms. We've also got some kind of atoms which have the building block to be ions. They also come in your way. What about oil? But it will show everyone. Okay, good. So what we can say now is that we also got some solids which are also having its building block to be ions. For instance, we talk of sodium chloride, NaCl. NaCl. We have sodium ion and chlorine ion. So it's also different type of solid. The common salt we use in our houses. We talk of also the molecular, like sugar, is also molecular solid. So with this, you can see that we've got different types of solid. And also got the allotrope forms like that of diamond, they form the allotrope. So they are also in a different category of what? Of solid. So basically, we say solid is a state of matter with loosely packed building blocks. Characteristics of solid. Okay, so look at the characteristics of solid. Good. We can see there are little or no spaces between the building blocks, not molecules. There are little of solid. We said there are little or no spaces. There are little or no spaces between the molecule or the building blocks of what? Solid. Now what we mean here is that there are some solids that are spaces between the molecules. And there are some that the spaces are very, very tight. For this one, like this one that I'm having, there are spaces between this. So during endothermic change or during endothermic reaction, whereby I expose this one to extensive heat, what happened to it is that it absorbs the heat. And the moment it absorbs the heat, you realize that the spaces start to disintegrate by taking more kinetic energy. So the particles start to speed up and give away the spaces. So this one is it's a molecular form because it is rubber. It's molecular solid. The rubber I'm having is molecular solid. So the kind of energy required for this one to change from one state of matter to the other, it is lesser than when I take something like wood or metal. Metal will require more. And there are some that require little form of energy to break away, disintegrate the building blocks between them. The toothpaste I made mention of is a typical example. The local palm oil, palm oil, if it's allowed to be there, you see, it becomes cake. That cake thing, you can draw your hand through, you can just use the finger to partition it into two. This means that there are space, but you can't use just a hand to partition this one into two. Before you can partition this one into two, unless you use extensive force. So the spaces between the molecules of the marker I'm having are stronger than that of the cake palm oil. Or you can also talk of cream, normal cream we use, or toothpaste. Good. So that is one. Again, if you look at that of ions, those that are made of ions, like the sodium chloride I made mention of, the calcium carbonate, most of the solid we use that are the inorganics. These ones are made of ions. They are also closely packed. At times, some are made in such a manner that after the reaction, they are loosely packed, but in all, they are tightly packed that there are little or no spaces between them. So that is the first one. Good. Two. During what we call endothermic, when we talk of endo means addition of energy from the environment to the surrounding. If I take any energy from external, for instance, I want to heat water. I want to warm, let me say, I want to warm water in order to bath. That is what some people do. So what I do is I pour water into a cooking pot. Then I send it to the burner. Then put it on it, then light. Now when I light, there is fire coming from the environment. That is the environment of the water. The environment contains the heat, and the heat will move from a point where the temperature is very high to the point where the temperature is very low. That is the transfer of heat. All these ones will be looked at when we are doing the physics. So because of that, the water will now take heat energy to become warm. So we said it's endothermic change. So during endothermic change, most solid change from solid state to liquid state. So it's during endothermic change. So we say during endothermic change, solid, some solid, because not all solid, change to liquid. Example, ice block to water. Now this process is what is called melting. Melting. Note. Melting point is the temperature at which solid changes to liquid. Is the temperature solid so melting point is the temperature at which solid changes to gas.